In Lecture 4, we're going to start talking about coordination chemistry. There's a rich history behind this topic in inorganic chemistry, and I want to present to you some of the background today. First, what are coordination compounds? There are two components to a coordination compound. It must have a metal cation, and it must be surrounded by ligands. So, for example, when looking at a coordination compound, you'll notice that it contains a metal cation at its center, and it will be surrounded by small molecules or ions that are known as ligands. In this slide, I show you three examples of coordination compounds. This is one of the most important coordination compounds. This is platinum bonded to two chlorines and, yes, two ammonias to form what's called cisplatin. In the middle example, you see calcium surrounded by this big molecule, EDTA, and it ends up bonding 6 times to the calcium cation. In the third example, you see an example of iron, an iron cation bonding to the pi systems in two cyclopentadienyl rings. We'll talk about all of these different types of coordination compounds as we proceed. Let's talk first about how bonds are formed in coordination compounds. We can think about the bonding concepts that behind the formation of bonds in coordination compounds in terms of acid-base chemistry. We will talk about Lewis acid-base theory. Lewis theory is where electron pair donors are acids and chemicals that can accept electron pairs are bases. Metal cations with empty orbitals are known as Lewis acids. They can accept electron pairs. And small molecules with lone pairs of electrons are Lewis bases. Now, in coordination chemistry, we call the Lewis bases these small molecules with a lone pair of electrons that can bind to a Lewis acid, a ligand. In this example, you will see ammonia. It has a pair of electrons that are not participating in bonding on nitrogen. When the bond forms between the nitrogen on ammonia and a metal cation such as C2+, the two electrons are donated to form this bond. A ligand comes from the Latin, or the term ligand comes from the Latin, meaning to bind. A ligand is a small molecule, an ion, or an atom that donates electrons to a central atom in a coordination compound. And I give you three examples: Cl-, NH3, and NH2CH2CH2 NH2. Ligands are Lewis bases. More about ligands. We've talked about different types of ligands, but organometallic compounds are compounds that contain metal-carbon bonds. So the ligand has a carbon atom that can bind to the metal cation center. Some more examples of coordination compounds and their usefulness include this compound right here, alizarin, which is a red dye. It has this complex ring structure, a sulfonate bonded to Al3+. this compound produces a red dye. One of the most important anti-cancer drugs is known as cisplatin. The two chlorides are bonded to platinum. They are cis to one another, and the two ammonias are also cis to one another. Very, very important. This is an important anti-cancer drug. This, which I showed you the compound earlier, is known as ferrocene. Ferrocene is known as a sandwich complex. We think of ferrocene as having an iron meatball in between two pieces of bread, the two cyclopentadienyl rings. This is an orangish color compound that's made in many inorganic labs. And finally, we have calcium, which is taken up by EDTA. Now, EDTA can be a poison because it can bind almost any metal cation because it has many spots that can bind to that metal center. Remember that organometallic compounds are compounds that contain metal carbon bonds. The carbon must be part of an organic fragment. And I'm giving you examples here. So in this first example, you see titanium bonded to two cyclopentadienyl rings and double bonded to a CH2 group. In the second example, you see chromium. Now it's bonded to a lot of carbon monoxide ligands, but the most important thing to note is that it's also bonded to this carbon-containing ligand that is part of an organic fragment. The same goes for the third example. Chromium has formed a triple bond with carbon bonded to a benzene ring. And as seen in the first example with titanium, iron is coordinated to two cyclopentadienyl rings. Let's discuss briefly the history of coordination chemistry. The first coordination compound was observed in the 1800s when Tassert reacted a solution of cobalt-3 chloride with ammonia, and he observed that a reddish mahogany-colored compound was formed. Unfortunately, Tassert never tried to do anything with the compound that he formed, so it was observed, but it went unexplained for over 60 years. In the early 1850s, other cobalt ammoniates were prepared, such as COCl3.6NH3 and COCl3.5NH3.